Hi, everyone, and thank you for attending our webinar today. I'm Daisy Devesague, the AWS Container Specialist in our go-to-market team, and I'll pass it to Rafa for intros.
Hi, everybody. I am Rafa. I'm the product manager for AWS Proton. Very excited to be here and share something of what we've been working on with Proton.
Awesome. Thank you, Rafa. So let's get started. So looking at our agenda today, we'll go over introduction to AWS Proton. So I'll be giving you a quick, overview into what Proton is and what are some of the aspects of Proton that are very beneficial to customers and how they've been leveraging some of it. And then Rafa will cover some best practices with creating templates, infrastructure templates, and then he'll go a little deeper into writing tips for the templates themselves. And then I'll touch upon the multi-account support and customer managed environments in AWS Proton. And then we'll follow along with the demo. Okay, so if you look at the environments in many enterprise customers, so large organizations that have multitude of development teams and a centralized governance or platform team, as we call them, there is definitely one thing that you'll see in common, which is the need to standardize the infrastructure and how it's deployed. So often than not, there's multitudes of applications that are running in these organizations. And as you drill down into any of those applications, you can see many infrastructure components that are constituting the underlying layer. And to make sure that these infrastructure are set up correctly, that could become a full-time, job of its own and a pain point for sure. So when you look at these organizations, the platform team really wants to focus on empowering the development teams to focus on code only. So developing their code, shipping their code without having to wait on any infrastructure components to be deployed for them or deploying it themselves, and really be confident that everything they need to get their application up and running is there available to them and ready to go. And to achieve that goal, many customers in enterprise leverage tools like CloudFormation or Terraform, which are great tools for templatizing, which means creating templates where you can define your infrastructure once as infrastructure as code, and those components can be reused many times. And there's added benefits to that for customers. For example, making sure that they know what infrastructure is being deployed, keeping a track record of what is it that the different applications are using under the hood. Also, being able to leverage the underlying infrastructure, especially for developers, without necessarily really knowing all the intricacies of how do I deploy, like my compute, my DNS, my load balancing, and things like that. But the drawback of doing templates, infrastructure as code, could be that it's hard to modify. Sometimes your development teams need some changes to these templates, and now they come to you as an infrastructure team, and they ask you to make some changes. And now there's a lot of back and forth. It could be that there's some downtime, and you're changing some templates. And then another challenge could be to keep them updated. When new versions come up, how do you make sure that you're always updating the versions of your templates? And also kind of going after the templates that are already deployed and making sure those versions are up to date as well becomes a challenge. Same thing for changing templates in a multi-stage or changing developments. It's really a question of how do you make sure that every template out there is at the latest version? And when you need to make a change, how do you make it quickly and in a scalable manner without interrupting your business? So one thing that customers come up, the customers that we talk to, some decided to create their own SaaS tool. So their own platforms to abstract their infrastructure underneath the hood so that developers can focus on code and they don't have to manually set up their infrastructure themselves or wait after their platform teams. So those tools could be good for some of the customers, but there are definitely a mix of positive and some drawbacks. So, for example, sharing templates. One thing, when you create templates and say you have your own tool for sharing those templates, now how do you make sure you have a mechanism in place so that when your developers do self-serve themselves these templates, how do you make sure they're updated? Or when a change is requested, how do you keep track of those changes and make sure that you're always at the latest versions? Could be a challenge. There's also centralized provisioning. So platform teams that are in charge of these tools have to, they have full control now. They can decide on, what templates are created, what templates get made self-serve to their developers. But now it's more of a very central approach. So every request a developer has, they have to go to the central team and wait for them to get back to them to create new templates. It's a lot of micromanagement in a sense, and that could become a bottleneck of its own. Now, some customers, instead of creating a tool themselves, they use tools out there that are pre-packaged and pre-built for them, for their developers to just consume those tools so they can deploy their code without having to worry about the underlying infrastructure. And the major drawback in that situation is that those types of tools are hard to customize. So it's really difficult for a platform team to be adding in guardrails, matching the governance that's in place at their organization. And then lastly, it's creating your own internal tool. So like I mentioned, the SaaS tool, if you're creating a tool now on top of all the different tools that you already have, that could solve some of your problems in terms of control and maximizing speed for the platform teams. But that could be very expensive in the sense that now you need a dedicated team that makes sure that all the version controls in place, that all the templates are updated, and they can go after each development team and making sure that everything they consume is at the latest and keeping up with the pace of innovation of the tools that they're leveraging and the infrastructure. So speaking with these customers, that's really what STEM AWS Proton. So AWS Proton is a solution that sits really in the middle. It's an ideal solution where you have a little bit of both of what we just discussed. So you have your infrastructure administrators who create these templates leveraging CloudFormation. Once they create these templates, they'll be able to publish them into Proton so that you have a self-service catalog for the developers. Now, the developers can log into AWS Proton, see what are the templates available to them, pick and choose from that list, and start consuming them. And now, to address some of the questions of, how do we do version control, for example, or what are some of the features that really alleviate some of the issues that I talked about earlier? So in terms of requesting different changes into the templates, that's something that you can do via AWS Proton and have a seamless, more of a collaboration between your administrator team and your development teams. And AWS Proton also gives a centralized way of monitoring and updating the templates that are available. So you can do version control right off the bat from AWS Proton, logging into the console. AWS Proton also integrates with CI/CD pipeline. So if you have your pipeline already set up and you'd like to have that fed into Proton, AWS Proton, so it does it for you, you can have the deployment done that way as well. So now I'm going to pass on to Rafa to cover best practices.
The next sections are going to talk a little bit about the best practices that we see in using Proton and how Proton enables you to use that, as well as some tips of things that we found that are useful when you're writing your templates. Now, here is the key thing to think about. Like Daisy has been saying 1,000 times already, at the core of Proton are those templates, right? Proton is not a tool to allow you to create new templates, but rather to allow you to use them in the most powerful way, in a way that in your organization you can have the configuration that you need, yet your developers are managing everything themselves, and they are able to move fast. And so when we think about Proton today and in the future, we try to think about the key paradigms of template operation. What makes a template successful? Having a template somewhere available that never changes and is hard to track, it ends up being a drag, almost like a bottleneck. So how do we make that work better with Proton? And so we're going to touch on 3 points, 3 aspects that we sort of obsess about when we work in Proton, and they are driving a lot of our roadmap in the present and in the future. Let's start with collaboration. So at the core, it's the idea that everybody in the organization has a vested interest in making those templates available and making them better and using them for their infrastructure. So we need ways and mechanisms to expose the contents of those templates to all the stakeholders and enable collaboration between them. What you see on the screen is screenshots from a public repo where we actually have Proton templates that people can show and look and make comments and make changes. We had community members show up and say, you should change this or that thing. Maybe the default container image needs to be improved. It's a first step into making that process collaborative, right? You can be in a world where all of your templates of the enterprise are located in a shared location, and different stakeholders, be it developers, security teams, infrastructure teams, can show up, look at the contents, and start changing them. What this allows you to do is, one, provide confidence to people. I know what's inside here, so I'm not being given something that I am unaware of. I actually can go into the details if I need to. And it allows you for fast evolution, because you can actually have people use all of the benefits of Git to continuously improve on that. For us, this means 2 things in Proton, things that we do today and things that we're going to be doing in the future, right? Right now, you can write Proton templates in CloudFormation. And as Daisy said before, Proton allows you to version that template. And the beauty of doing that is that if somebody is using a template, you can quickly use Proton to see, are they in the latest version? Do they need to move up one version? And so as the template evolves through the inputs of the many stakeholders, you continuously carry your infrastructure with it. In the future, we are working on defining templates using Terraform, yet another avenue to communicate the content and have people collaborate. Very important for us, and we had a handful of people ask for this, syncing of templates with a source code repository. So going back to the image before, imagine that you have your templates in a central repo, and one of the things you can do is just make a pull request, and the moment it gets merged, immediately Proton creates a new version of the template and is ready to use. That allows for even faster iteration and a more smooth process from ideation to actually have the template changed. The last 2 pieces are about enabling collaboration in a different way. So one of the limitations often of a template is that it might not fit exactly what I need to do here. So what's my path forward? Well, I could just go away from the template and do my own thing, but now it's going to be hard to know what's going on. In Proton, we are embracing this idea by bringing in new features that will allow developers to customize those templates as they are going to use them. One of them we call template modules, a world where I can say, I want to pick one of these specific templates, but I'm also going to want to add a database to it. And I choose the database module, which also contains approved infrastructure. And the other is custom infrastructure, which would allow developers to actually provide their own set of resources that they need and have Proton basically be responsible for incorporating an infrastructure and gather approvals if need be. And so as a developer, you can still use Proton as a tool to give you the central template that you're looking for and then complement it as needed. These are all items in our roadmap. Our roadmap is public, is on GitHub, and we're going to be working on them. We definitely welcome feedback, suggestions, or ideas on how to make them awesome for everybody that's going to be using them. But we are confident, and based on customer feedback, that these tools will allow that collaboration at a new way without slowing down developers or taking away from that central platform team the capacity to know what's going on in the infrastructure. Moving on to the second one, the notion of self-service. So one of the issues or complexities with templates is that even if you have a template that defines the full infrastructure of maybe one of your microservices, you're probably going to have to do a bunch of work to get your whole end-to-end deployment ready. You have multiple stages, and then you have a pipeline. And so you might have to run that template multiple times, once per stage, and then gather a bunch of outputs and configure your pipeline. And as a developer, you might have to go to a handful of different tools to get all of that going. This is compounded by the fact that your environments are not always the same. Very often, I think about examples like customers that are working in retail and where every different store is basically a different deployment environment, which allows you to isolate one store from the others. That means that the microservices are oftentimes going to be changing where they are deployed to. And I want to be able to make those changes quickly and in a straightforward manner before having to constantly go back to the map of templates that I'm using. Proton aims to be the one end-to-end interface for this. With Proton, you can deploy your template to multiple stages of deployment, different environments, multiple production environments, and have one single pipeline for all of them. So in the example that's on the screen, it's a very simple example, but I could have my checkout microservice that I have my code, I make a PR, I merge it, and immediately my pipeline runs. It creates a container image, it deploys it to staging, it runs a bunch of tests, and it deploys it to production. And I managed to get all of that configured through the single Proton interface. Tomorrow, we need to deprecate our existing production environment and create a new one. I can go to Proton, change the corresponding instance, my pipelines adapt accordingly, and everything keeps working the same way. And so as a developer, I experience the capacity to get all of my stuff deployed in the right locations, in the right order, through one single interface. We believe this becomes very, very useful as you grow and continue using the service because it gives you that level of flexibility. And then to finish is the updates. So we keep talking about the same thing, and honestly, those are the key core points of what Proton does. But templates are dangerous because they are hard to keep track of, because people are using them, and then you have different teams that are in different versions. And at some point, somebody's going to be sitting there thinking, well, has everybody moved to the latest one? Does everybody have what they are looking for? This particular new version has a major security fix that we want everybody to be using. Is everybody using it? Well, once again, by virtue of having Proton be the one responsible for creating all of those services, you can have Proton tell you, wait, this one is not in the latest version. I highlight at the bottom 1.0. This is actually Proton warning me that this particular instance is not running the latest version. And at the top right, you can see a couple of buttons that let me move there. I can click those buttons as a developer, or I can click those buttons as an administrator. It doesn't really matter. But what really matters is that I'm able to quickly see what is the latest version, is everybody using it? If you are not in the latest version, what version are you on? And so through that, you can make that template be an actual living embodiment of my right infrastructure that I can aim for everybody to be on without having to individually choose teams and ask them, are you running that latest version? And so if we look at these three components together, this allows us to A, create templates that are backed by the whole organization, by our shared knowledge and understanding of what we need to do. B, are fully accessible to everybody to actually use end-to-end in their deployments. And C, they can be updated. Now you truly have a template that is useful for you on an ongoing basis, that is giving people speed and is giving administrators truly the capacity to ensure that the infrastructure is what it should be. So that's what we're very excited about Proton. There are lots of things that we want to do. Again, I encourage everybody to visit the public GitHub roadmap to see more details. But those are the key aspects of template management that we are building Proton around. The next topic for today was a bit about some tips about writing templates. These tips come from lengthy conversations with many customers since we went preview and then GA about some things that are often pitfalls or concerns or steps to think about when you're building your Proton templates. We can't deny that creating a template like this that you can customize and move to in the future is not something that you do in 5 minutes. It takes a bit of work to think about, to strategize, to iterate. And as much as we're looking to make that experience better in Proton itself, it's also important to have in mind some of the key elements of that process. So we're going to go through 4 things that oftentimes are discussed in these customer conversations. Let's start with the first one, environment versus a service. I will start by saying that many of these words are sort of overloaded at this point, and they are using for many different reasoning. But when you think about Proton, you want to think about environment as your shared stuff. These are the resources that many different services are going to be using. So in this particular example, in this particular template that we're showing on a screen that I'm actually going to use for the demo later, the environment contains things like the VPC and the subnets, the cluster, the internet gateway, and it says the ECS cluster again, the execution role. So these are things that many different environments, that many different applications are going to be using. On the other side, we have the service template. This is what actually developers are provisioning. So at the time of creation, these are the things that are going to happen. You're going to get a Fargate task. They're going to get, in this particular case, a load balancer with the target group, the auto-scaling policy, the alarms. Now, there is no hard and fast rule for this. Different customers will use different approaches. And so in some cases, the environment might actually be quite bare because you want most things to be part of the service template, and that's okay. It's key, however, to spend some time thinking about what do I want in my shared resources, what do I want in my individual and service instances. Keep in mind that as you load environments and deploy more things to them, those environments become more critical to your infrastructure. So you want to make sure you have the right things there, and you thought carefully about what they are there, and you're not moving them back and forth very frequently, just to simplify your life. So that's step one. Step two is to think about provisioning outputs, and the next thing I'm going to talk about, which is namespaces. So I will show all of this in the demo later. I didn't go into details in this presentation on how you create a Proton template. But at the core, what you are doing is you're taking infrastructure as code templates, and you're going to be parametrizing them to indicate to Proton, these are the values that you're going to be using at the time of creation. And Proton will use that plus the information provided when you are creating a service or an environment to actually render the complete template. One of the key aspects to think about is that some of those parameters are not provided by the infrastructure team, by the development team, are actually outputs of provisioning the environment. You can see examples here, but if I create a cluster, I'm going to need that cluster name to deploy my tasks into it. So one of the things that happens in Proton is that all provisioning outputs of the CloudFormation template that defines your environment, which you can see on the left side of the screen, are seen and recorded by Proton as provisioning output from that environment, which you can see on the right. And we will see next how Proton is going to be using that to actually populate the corresponding fields in the service instance. And we can see that here. I very much encourage everybody to go to the Proton documentation to see more details. But when you are working with Proton, one of the things you're going to be doing is you're going to be using these Jinja parameters that we can see here in double curly brackets to represent different types of inputs. Environment inputs or service system inputs are provided by the user at the time of creation. Environment outputs are the ones we just saw in the previous screen. And in addition to that, Proton provides access to some fields that are generic for every single resource, like name. There are a couple more that are in documentation. As a platform team who has an infrastructure as code template and is looking to bring it into Proton, this is where you're going to spend most of your time. You're going to be thinking, what components of that template am I going to parameterize? And after parameterizing, how am I going to have access to that information? Is it going to be given to me by the developer when they are trying to provision their service? Or it's actually something that comes from the environment? We have a couple of people in the public GitHub roadmap asking for new types of variables to use or new namespaces, which I think is very exciting, and we'll keep working on that. So this is a living list, but this is the core of your thought process when you're parameterizing your template. And to just add a couple of things to that, we want to make sure that it's clear that you can use all of the power of the Jinja as a templating engine to make those parameters work for you. So I have 3 examples here that we ran into, and we spent a bit of time trying to make sure we did right. The first one is probably my favorite, but oftentimes you might have AWS resources with different limits for the character counts. In particular, this example at the top is taken from the need to name a target group. A target group has a limit size of 32, and the name has to be unique across different instances. So what we did is we used this truncate functionality from Jinja to make sure that the service name and service instance name were appended properly, but then we limited the scope so that it wouldn't run afoul of those limits. This is just one of the ways you can do it, but this is one of the avenues that Jinja gives you to make sure that things match in your needs. Looping through multiple items is something that you can do. The example in the middle is a perfect example of our pipeline. So one of the beauties of doing a loop like this is that I can create a pipeline template in Proton that is flexible for the number of environments that I have. I loop through each of one of my service instances, and I'm going to do a bunch of work on it. So in the example before, if I have one production environment and tomorrow I add another, my pipeline is automatically able to absorb it. It's just another item in the array of service instances. I'm going to populate it. I'm going to deploy to it. No problem at all. And then the last one is if statements. We've had a couple of ways to see this work, but as I said before, one of the things that you want to be able to do as a platform team is embrace the idea that not all developers are going to use exactly the same template. Maybe there are a couple of optional components. You can include those themselves into the template. You wrap them in an if statement, and then you can have a variable that defines true, false, do I need this? As a developer, at the time of provisioning, I can make a decision. Yes, I need a database, and then the if statement triggers, and the infrastructure is provisioned. So these are 3 examples of 3 tricks, if you want, or tips that we've seen customers use and we've used ourselves to populate our templates. There is a lot to experiment there, and there is a lot of ways that you can use Jinja and smart ways to make this happen. But these are some suggestions that we've seen work well for people and help them get started with creating their own templates. I will say before I hand it over to Daisy again that, as I said, a lot of the work, all of the work of working with Proton remains on parametrizing those templates and keeping tabs on them and keeping them updated. So there is a bunch of work to do, a bunch of experimentation to do there as a customer. We have some exciting avenues that we're going to want to make that easier for customer and want a feedback loop and that experimentation loop to be faster. But definitely this presentation suggests some ideas on how to make that work. Daisy, you want to talk about customer managed environments and multi-account support?
Awesome. Thank you, Rafa. So I think this is a good transition to the section about customer managed environments and multi-account support. These 2 features have been highly requested by our customers who have tried AWS Proton during our preview period. And as we went GA a couple of months ago, we actually released these 2 features. So like Rafa mentioned earlier, most of our customers are spending their time actually looking at the parametrization. So how do I create those parameters for my template so that when a developer comes in, they can populate those parameters that were set up by the platform team. But so a major request in terms of customer managed environments is for those customers that have already deployed their templates. So let's say they created CloudFormation templates that are already set up to deploy a Fargate web service, for example, or touching some serverless Lambda instances. What do we do now when the templates are already in place and they want to use Proton? So you can bring your existing CloudFormation templates into AWS Proton now. You don't need to recreate them. You can just take them and start using them. There are just a few things that you need to really look into, which is, like I mentioned, the parameterization. So creating your schema and making sure your output variables are set up. So this is really, even if you were to create a new, you'd create your CloudFormation template, and then you spend some time adding in the parameters. What are values and parameters you want your developers to input, or maybe you're hard coding them for them, depending on the governance at your organization. So in that sense, you'd be able to use your environment as a standard environment. you wouldn't need to worry about redefining your templates. And this is very big for customers that are already leveraging, like I said, serverless or containers, because they'll be able to bring in the templates that they've already defined. So this next feature about multi-account is really giving you that supportability to register your templates into multiple accounts. So when we were doing preview period, some of our customers who've leveraged AWS Proton gave us as feedback as we need to deploy to multiple AWS user accounts, for example, or we have accounts that are split for like test, dev, and prod. And we want to make sure that there's this delimitation between what accounts can register and which ones we don't want to have templates do, and really being able to manage the multi-account aspect. So that's something you can do now with AWS Proton in simple steps, as you see here. So you can request a connection. So your template would be requesting for the connection to happen, so you can deploy them. Once the connection is accepted and it's an account where you want to deploy, then using AWS Proton, you can just start deploying your environment through that connection. Okay, great. So I think that's the end of my section. I'll pass it back to Rafa for the demo.
So let's go on with the demo. To do this demo, I'm going to be jumping back and forth between the Proton console itself and GitHub. And the reason is that, per my comments before, a lot of the work of working with Proton is actually managing those templates. And so I will want to show how those templates are used right now, how we customize them and we bring them into the service. Before I start, there are a couple of concepts that we mentioned many times in the presentation so far, but I will double click on them. The idea of environments and services, which I spent a bunch of time talking about before, so I won't repeat myself. You've heard me say service instances multiple times. A service instance is a service in an environment. So when you think about deploying, the example that I had before was checkout on staging and on production. Each one of those are two different instances. And then, of course, templates, which is the word of the day, is something that we are using to define those reusable blueprints that Proton is going to be relying on. So what I want to do today is I'm going to show you an environment template. I'm going to show you a service template. We're going to deploy the environment. And at least we'll preview how to deploy the service. We won't get to deploy the full service by the end of the demo, since it takes a bit. It's actually deploying the Fargate task, but you should see how it works. I'll touch upon some of the other pieces like multi-account support and customer managed environments, just so everybody can have an idea of how this works. But let's start with environments. So as I said, in this GitHub repository, which is public, we have a handful of sample templates that people can use to learn or to start deploying themselves. For this demo, I'm going to use the load balance Fargate service. And so in these particular ones, we actually have both an environment and a service template. We're going to start with environment and then move on to the service. So the environment is mostly made up of CloudFormation template that represents those shared resources. And I listed them in a previous slide. So we shouldn't be surprised to see things here like a VPC with a couple of subnets, an internet gateway, an ECS cluster, etc., etc. What is different about this template versus a regular one is that it's parametrized. And again, if you remember, it's using the same namespaces that I was talking about before. We're basically telling Proton that you're going to get an input to represent the IP ranges for the VPC and the two public subnets. How do we tell Proton to gather this information? We use the schema. The schema is a file written in the OpenAPI specification where we actually provide some data points that Proton can use to request this information. In this particular case, the type, a description, and a default value and a validation pattern. Very straightforward. What's going to happen based on this is that either when using the CLI or the console, Proton will render the request using this information, and then it will take the inputs and inject them into the CloudFormation template to actually run the CloudFormation template. So let's go to Proton to see that now. I have a handful of environments here. I'm going to look to create a new one and say I'm going to choose this one. Fargate VPC is actually the same template that we were looking at right now. Proton asks me, first of all, if it's in this account or another account. I'm going to use this account for now. I have a ready environment in a different account that I can show in a minute. We have to give it a name. We're going to call it demo environment. This is an demo. Now, this one is interesting. We're going to give a role to the environment. What's happening here is that Proton will use this role to provision this environment and all of the service instances that go into it. This means that you can give Proton a role here with the permissions that you're looking for. And if developers show up looking to deploy something using Proton, it doesn't matter they don't have those permissions. In other words, I can choose one of these roles available here. This role has permissions, for instance, to create IAM roles, which is needed to deploy this infrastructure. I can have my developers only get permissions to deploy in Proton, and things will work anyway, because Proton relies on this particular role and permissions. This allows you to create that separation of ownership between the actual infrastructure provisioning engine and the developers themselves. I want to clarify that this is not a requirement, meaning your developers could have full access to everything, and that would be okay. It's your call, basically, how open do you want to be. But this creates that layer of control and ensures that Proton is able to consistently provision the infrastructure no matter what. I don't need to add any new tags at this point. And now Proton is asking me for those 3 parameters that we saw before. It's giving me the fact that they all have a default value visible here. So at this point, I don't have to make any changes. And I'm ready to go. Now, when I click create here, what's going to happen is Proton is going to take these 3 parameters. It's going to inject them into the CloudFormation template as we saw before, and it's actually going to create the infrastructure. I can click create. I can go back here, and it's now creating. While that is happening, I can show you a previous one that I did. This is very much the same infrastructure. So we have here all of the details. We have the CloudFormation stack that was created. And we have as well these outputs that I mentioned before in the presentation. These are going to be used when we try to deploy something to this environment. One final comment that I want to make is that all Proton resources are tagged with a series of automated tags that identify them. In the case of environments, is the account that created it, the environment, and the template. These are also passed down to CloudFormation. And so it's easy for me to use the tags search to identify all of the resources that were created as part of the environment, or all of the resources that were created as part of this template. It's another avenue to help the platform team see what's going on with the infrastructure. All right, great. So we have an environment. The environment is being deployed. Let's now move on to the service. And I'm going to do something that looks very similar. I'm going to go back to GitHub. I'm going to look at the infrastructure. And I have equally a CloudFormation template. This one is way longer. It includes my task definition, my auto-scaling policy, all of the alarms, etc., etc. And it's equally parameterized. So if I go back to the top, we can see here inputs like the task size, which are going to be provided at the time of creating the service, and outputs like the easiest task execution role, which was generated here. Here is how you can see how Proton is able to flexibly adapt to new environments showing up. If you create another environment, the one I just created, it's going to have all of these outputs available, and Proton is going to be able to inject them here into a new instance. So you can seamlessly add and remove instances from services as your environments change. The service also has a schema, which has the exact same structure as the previous schema, including some parameters with some information about them. And optionally, in the service, you have a pipeline, like we can see here. Now, this pipeline is a code pipeline. It's all specified in CloudFormation. This is CloudFormation also parameterized using the namespaces that I was describing before. Here is where you can see that loop. So what is happening here is that Proton is going to be, this pipeline is going to have basically a deploy loop for each one of the instances. And what the deploy loop does is simply take the build container image based on my code, deploy it to the corresponding instance using Proton, and then run a bunch of tests. The beauty of this is that I've had some customers ask questions about how do I promote my builds across different stages, and this makes it seamless. You create your build stage, you create your image, which we store in render-service.yaml here, and then we are iterating over our different instances and deploying to each one of them. And as I said, if we add another one, it gets added to the queue and the deployment happens. So if I go to Proton now and I go to my services, I can create a new service here. And say, let's try to create this one based on this. We're going to create a demo service. I point to my branch in GitHub. For some reason, it adds spaces here, which is strange. Proton relies on an AWS service called CodeStar Connections to connect to your Git repository. Right now, we support GitHub Enterprise, GitHub, and we support Bitbucket as well. But we can keep working on those and adding more as need be. Now we're going to be asked for information that we saw before in the schema. So for each one of my instances, I'm going to have to choose an environment. Right now I have 4. There is one missing, which is the one I just created because it's still in deployment. But I can choose any one of them. I can give it a name. I don't need to provide any of this input because it's already in the parameters. I can add another instance, say to deploy to production isolated. And then I have my pipeline inputs here. And then we have all of the components here. So what's going to happen now, if I click create, is that Proton is going to create, in this particular case, 3 different CloudFormation stacks. One for stage, one for production, and one for the pipeline itself. Those are 3 different components. It will use the combined information that I provided here with what's available from those environments. So I can just go ahead and click create. Now, this is going to take a bit, and we're not going to see the end of it by the time we're done with this presentation. But I wanted to actually stop for a second and show this service. This is a service that I created before that has 3 different stages. And the beauty of this is that each one of these stages is in a different type of environment. They are in this one, which is in an altogether different account. You can see my account here. You can see the account in which this is. They are also in this one, which, to go back to what Daisy was talking about, is actually a customer managed environment. So Proton doesn't have any CloudFormation stack that is running. It's just capturing the input, the outputs, and using them to make the provisioning. And then we have a standard one, which is this one. By the way, I'm seeing now that the one we created is deployed successfully, and it's all ready to go and to be used. So a couple more things to touch upon. The first one is the notion of templates and versions. We can go here to one of my service templates, this one. And we can see here that I've been playing with versions ahead of this presentation so we could show how it works. As an administrator, if I want to change my template in any way, I don't need to go and create a new one. Rather, I can create a new version. Versions can be major, like 1 to 2, or minor, like 2.0 to 2.1. It depends on how big the milestone is. It depends on if there are new parameters that I want to record. But at any point in time, I can look at my existing services and see which version they are using. Now, I actually moved all of this to the latest version, but you saw before that if any one of them is not in the latest version, Proton will warn me, and I will be able to make an update with a single click. So I could go to multi-step here. I could select one of the instances, and here I have an option to update the instance. This can be done by the administrator or by the developer. The other piece that I wanted to touch upon very quickly is, as we said, multi-account environments. So I mentioned that this particular environment, production isolated, is in a different account. How this works is actually very simple. I first, before this presentation, went to this account, and I created what we call an environment account connection. I sent a request to the current account, 6226, to manage something. It shows up here. I came from this account, I accepted it, and from that point on, this environment shows up in my list of environments. The beauty of all of this, of course, is that this is transparent to a developer. So as a developer, I can show up I can select my correct environment and make the deployment, and I don't have to worry about whether it's in a different account and if I have access to it or not. Proton is taking care of that for me. And so this is the core loop of managing Proton. As an infrastructure team, I'm going to be playing with these templates. I'm going to be keeping them updated. I'm going to keep tabs on these services that I'm deploying and making sure that they are in the latest version. If they are not, I'm going to use the tools at my disposal to move them up, be either reach out to my development teams and explain what's going on, or actually just do it myself from here. But that's the continuous process that's going to be going on. I can also use these interfaces to get a quick look at, are all my deployments all right? Is everything okay? Do I have to pay attention to something? Did something fail? Do I need to adjust something? And so this way, you get all of that management from one single location, while the underlying components are still operating in the tools that you know, such as CloudFormation, ECS, etc., etc. The last thing I will say, it's important to know that Proton doesn't replace those underlying tools. So when we go here to this new environment that we created, I get to see this information, but I can always go to CloudFormation to see the details. So as an infrastructure team, if I today is spending my time writing CloudFormation templates, I'm still going to be doing that in Proton. And you're going to have this layer on top of it that gives me end-to-end management. As you can imagine, as I go through this demo, there are hundreds of additional things that we want to add. We want to incorporate additional health data, so it's easier to see what requires attention. We want to bring modules, like I talked about before, more ways to customize those templates. But this is the core loop of how to use Proton. We've seen very exciting successes using Proton today with customers. So we're looking forward for more feedback, more opportunities to improve the service. Well, that's it for today. Thanks. Thank you very much, everybody, for listening. Just a couple of data points here. You have the public GitHub roadmap available. It's been a phenomenal tool to interact with the community so far. Lots of questions, lots of suggestions. I've gathered input and scheduled meetings based on this. So please feel free to join. And I try to be as active as possible there. So show up, plus one the things that you want, make comments, and I'll be happy to interact there. And Daisy and I, you have our Twitter handles here as well. So you can also reach us on Twitter to discuss anything related to template management, Proton, and the broader process of delivering your applications. But thanks, everybody, for your time. I'm looking forward to doing another one of those soon.